Hello, everybody. This is Andy Pilc. It's day 39 of our astronomy unit. There are just 2 days left in this unit. So today we're going to be doing a lot of review of concepts that we've learned in the last couple of weeks. After you watch these videos on SpaceX, if you've never seen a video of a SpaceX rocket landing, it is like the coolest thing because they're one of the first companies to ever have like reusable rockets, which is going to be helpful in terms of like the economics and the reusability of hardware. So you can watch this video, but if you want to do a little bit of exploration, do some research and watch a video of SpaceX landing one of their rockets very, very precisely using rockets. Then you're going to watch a couple videos today to just review some of the major topics from this unit, and then you'll jump into the origin of the universe question bank. And in this video, I will be going over some of the multiple choice questions that we see in this bank. So, of course, always give these a try first on your own and then compare your answers to this review. So let's start going over it. Which evidence best supports the theory that the universe was created by an explosion called the Big Bang? So remember, everything is expanding for the last 14 billion years. And there are two pieces of evidence that we always find or that we can use to support the Big Bang theory. One is the redshift of distant galaxies and how more distant galaxies are increasingly moving away from Earth. The second piece of evidence is the cosmic background radiation, or leftover energy from that expansion about 14 billion years ago. So number one was choice two. Question two, we're going to need to use the ESRT. Which star is more massive than the sun, but has a lower surface temperature? So for this one, as we go up in the chart, stars are getting more massive, but it's asking for a lower temperature. So we're going to be looking to the right of our sun in the middle. So out of these choices, best option would be, it looks like Aldebaran, right? Because it's higher than the sun in the table, and it's more to the right, indicating a lower surface temperature. Question two is choice three. We'll keep on going. Again, we can answer this one in the ESRT using the electromagnetic spectrum diagram. Which color of visible light has the shortest wavelength? So in the table, as we are moving to the left, we're going to see decreasing wavelength. So out of these options, the best choice would have been violet because it is the most to the left out of the visible light colors. Question four. The planets are shown in their relative order of distance from the sun. Letter A indicates one of those planets. The center of the asteroid belt is approximately 503 million kilometers from the sun. Draw an X on the model between the two planets to indicate the center of the asteroid belt. So for this one, usually I would expect to see a scale. Oh no, so it's not drawn to scale. So for this one, we're going to have to use the ESRT again. With this information that the asteroid belt is 503 million kilometers away from the sun. And you can also remember that the asteroid belt does separate the terrestrial and the Jovian planets. So that would mean it's right in between Mars and Jupiter. So we would expect to see an X right in between those two planets, Mars and Jupiter. We'll clear the screen. If it did have a scale, then we can use the scale and that distance to draw our X. Since it's not drawn to scale, we can just put it in between those two planets. Question five, the planets are shown in their relative order of distance from the sun. Letter A indicates one of the planets. State the period of rotation of planet A. Label your answer with the correct units. So planet A is the furthest one out, which means it would be Neptune, right? Because that has the furthest distance from the sun. And the question was asking about the rotation of the equator. So we're going to look for period of rotation at the equator, and we would see 16 hours, or it would take 16 hours per rotation. Yeah, so there we go. Question six, same heading again. Question is, how many million years ago did Earth and the solar system form? If you do not remember when Earth and the solar system formed, you can actually find it here in the geologic history table, where we see estimated time of origin of Earth and the solar system at 4,600 million years ago, or in other words, 4.6 billion years ago. Since it's saying how many million years ago, we can put 4,600 million years ago. A lot of answers there in the ESRT, as long as you know how to read it. Let's continue. Let's go to number, oops, sorry about that. Let's go to number 7. Same heading again. Calculate how many times larger the equatorial diameter of the sun is than the equatorial diameter of Venus. So again, we're going to be using the solar system data table. And we want to compare the equatorial diameter of the sun to Venus. And to do that, we can pull up a calculator. And we are going to divide how many more times the sun is. So we want to take the sun's diameter. So 1,392,000 divided by the diameter of Venus. So we have 12,104, and we'll get this number here. So the sun's diameter is about 115 times as wide as our sun. Again, 115 times as large as Venus. Let's go for number 8. Same heading again. Identify the process that occurs within the sun that converts mass into large amounts of energy. If you've watched my videos before, you know that I love these questions because they're layups, they're easy. Whatever it's asking about how suns create their energy is through the process of fusion. And fusion is combining lighter elements into heavier elements. Not to be confused with fission, which is separating elements. Fusion is combining elements. Smaller elements, lighter elements into larger, heavier elements. Question 9. Which evidence best supports the theory that the universe began with a massive explosion? Again, we have 2 pieces of evidence. We have cosmic background radiation, which appears to be choice 1. The second piece of evidence is redshift. And none of those are here, so the best choice would be choice 1 for that one. Question 10, Halley's Comet. So the diagram represents the orbital paths of the 4 Jovian planets and Halley's Comet around the Sun. Halley's Comet has a revolution period of 76 years. In 1986, Halley's Comet was at perihelion, its closest point to the Sun. It's going to be right over there. Letters A, B, C, and D represent locations of Halley's Comet in its orbit. Location D represents Halley's Comet at aphelion, its furthest point from the Sun. The comet's tail is shown at perihelion at locations B and C. So let's take a look at this question. Compared to the orbit of Jovian planets, the orbit of Halley's Comet is, so when we see this orbit of the comet, it's really kind of like flattened. It's kind of a weird circle. And another word for weird is eccentric. So we know that this orbit is more eccentric, which would mean that it's more elliptical. So we can eliminate choices 1 and 2. And if it's more elliptical, then we can expect to see a greater distance between the foci. And this is kind of taking some notes out of like the Kepler's laws and the hands-on lab where you draw the ellipse using 2 push pins. As you move those push pins out and continue drawing your ellipse with a circle, then the ellipse that you draw is going to get more and more elliptical or more and more eccentric. So number 10 was choice 4. We'll keep on going. We'll get up to maybe about number 15, depending on how the diagrams look. So again, same information, same heading. Let's take a look at this next question. The diagram of our solar system represents, remember, geocentric is Earth-centered, which was wrong. It was proven wrong during the scientific revolution a couple hundred years ago. So we know that it's a heliocentric or a sun-centered model of the solar system, and that would mean the sun is in the center. So 11 was choice 3. Here we go again, same diagram, same heading. Which sequence lists the Jovian planets in order of increasing mass? So for this one, let's clear the screen here. For this one, we're going to be using mass, and you'll see that Jupiter is the most massive, then Saturn, then Neptune, then Uranus. So it's not necessarily in order of closest to furthest. There's a little bit of a difference. So we're going to look again for Jupiter, then Saturn, then Neptune, then Uranus. So let's look for Jupiter, Saturn, Uranus, Neptune. Choice 3 would be the best answer for, or the only answer, for question 12. I love these questions. Again, a layup, nice and easy. 13, slow chart showing the evolution of stars. We have massive stars and less massive stars. The force responsible for the contraction of a nebula to form a protostar. So remember, the process is fusion, but the force that makes things contract and come together from a nebula, a cloud of interstellar gas and dust, into a protostar, and then it's going to squeeze together and start making those atoms fuse together. But the force that does that is the force of gravity. Not too many other forces will be asked about on the earth science exam. We have the force of gravity, we have electromagnetic force, we have weak and strong nuclear forces, and then other forces that we have you would learn more about in physics class, like a spring or an elastic force. Not so much things that we talk about in earth science, and especially with the evolution of stars. Let's continue. Question 14. Whoops, sorry about that. Describe how the diameter and luminosity of a main sequence star change as it becomes a giant or supergiant. So we're going to look again over here. And as this happens, we can see it's going from a main sequence to either a giant, or sorry, a supergiant or a giant. So in this table, it's going to be moving up, meaning it's gaining mass. It's going to become more massive. And if we move to the right, we're going to see the temperature decrease. So the diameter would increase. The luminosity is also going to increase because it's getting bigger. So that's what it asked about. Diameter will increase, luminosity will increase. It didn't ask about the temperature, which we just saw decreases. Let's answer one more star question before we turn in for this video. 15. Which characteristics best describe the star Betelgeuse? So it's looking for color, luminosity, and temperature. So let's find the star. Betelgeuse, one of the biggest stars in the chart here. So let's take a look. The color is going to be orange-red. The luminosity is going to be, let's just kind of use this for lines, a little bit over 100,000 times as luminous as the sun. And the temperature is relatively cool compared to those other stars. So let's take a look. So we know it's going to have a low surface temperature, which we just talked about. And we did say a reddish orange with a high luminosity. So the best answer for question 15 would be choice 2. We'll take a pause right here. Again, make sure that you're checking your answers against these. If you haven't done so already, take a crack at questions 16 through 30, and then we'll review them in another video. I'll see you folks next time. Bye. Hope you found this video helpful.